Hey there and welcome! On today's video I will show you from FNIRSI the brand new DSO-153 that just arrived to the market. This mini oscilloscope is the third generation oscilloscope that started with one of my favorites, the DSO-150. It was a very simple, plain oscilloscope with a very nice case for that time and with a very nice price also. That will do exactly what was needed. Some years later, FNIRSI released the DSO-152, nearly with the same functions but a much better interface and layout. And finally was released this new DSO-153, and this time they cranked up the features. Now you have 1 MHz analog bandwidth with 5 megasamples per second oscilloscope and a new function generator that will output 14 different waveforms with adjustable amplitude. I have to make a small pause here to let you know that this device was sent by FNIRSI free of charge for this review, and no payment was made by FNIRSI to produce this video, and as always they will see it at the time you do, when it's published on YouTube. FNIRSI is a long collaborator with the channel and I want to thank them for sending this device for review, but I want to thank you also, my viewer and channel sponsor, that keep using the affiliate access links on the screen or in the video description for your purchases on AliExpress or Amazon. You pay exactly the same, but give the channel a big help with your sponsorship while using those links. That, by the way, can be used whenever you buy anything on AliExpress or Amazon, not limited to the product reviewed on this video. So again, a sincere thank you. Enough chit chat, let me start by showing you the key features. So we have here the box. It's a retail box, very small. It has this hologram sticker in it to protect the device. Let's start by opening. Okay, so let's see what we have inside. So we have the DSO-153. Let me take it out. Let's first see what was delivered with it. The normal quality assurance sticker. And we have here the charging cable, USB Type-C, very nice. And we have also this, this MX, I believe, connector to connect the oscilloscope with the alligator clips in the end. Yeah, a bracelet and the user manual. This is black and white, several language. It seems to have Portuguese. Let me see, just so you guys know, Chinese, English, Russian, and Portuguese. Yeah. So yeah, let's see what we have in here. Okay, seems well organized. We have here the infographics, so it's easier for us to understand what they mean, not only text. Seems very well organized, yeah. Kudos to FNIRSI again. Okay, something that I almost forgot to mention is that also delivered with this came this probe. This is the 6100, the normal probe, if I'm not wrong, and I am not. It brings the normal pack of rings and the screwdriver for calibration, but more important, we have this adapter. This is a MCX connector for BNC, and that's the socket that we have in here. That's a MCX. Now it's the time to talk about this video sponsor, PCBWay. I always use PCBWay for creating my boards with a professional factory quality, as you saw in my millivolt voltage reference board. It is very cheap to manufacture your PCBs on PCBWay. You can manufacture 10 PCBs for only $5. How awesome is this? And it is pretty easy also.
Just insert here the PCB dimensions and you'll have an instant code. So when you want a PCB, visit PCBWay to get your code, and if it is your first time ordering from PCBWay, you can use our access link for a $5 credit. And don't forget, they also have component assembly service, 3D printing service, and much more.
So as first impressions, this is the same form factor that it was the DSO-152. Yeah, still has these rubber buttons here on the right. We have this knob, this selector knob, the output of the signal, this little output for calibration, and the exit of the signal generator and the probe connector. In the back, we still have this stand, so you can have it on a vertical position. We have the reset button here on the left side with the charging light, and also the charging port USB Type-C, and might be used also to retrieve the image from this device and also to upgrade the firmware. On the bottom you don't have anything. You have on this corner the bracelet sleeve connector, or where you can attach it. And on the front you have also the power button in here. But even before testing, let me show you side by side. So you have here also the top vision of it, the front. As you can see, it's the same case, just a different color. Everything, not this side, this one. Everything seems equal. On the top, you can see, the DSO output. Okay, now is the time to test this. Okay, let's start by powering up the oscilloscope. The first thing that you have to do is use this knob on the top. See my finger, I already showed you, to select the language that you will use on this oscilloscope. Let's start with English. We have the main menu that allows you to use the oscilloscope, the signal generator, or go to the settings. Let's start by the settings. Let's see what we have in here. So in the settings, you can change also again the language. For that, you use this option on the top, press OK, and then you might use these two buttons to change the language. Press again in the top, and you are able to use it again to select the options on the left. Okay, so we have the language, we have the sound level and the image brightness. Also, you have the startup if you want to start on that menu that we just saw on oscilloscope or on signal generator by default. You have the theme, you have the blue and yellow theme. Let me change to yellow. Okay, I will keep the blue. Yeah. Again, we have the auto shutdown. Right now it's off, but you can have 15, 30 minutes or 1 hour. The version of the software, right now I'm using version 1.5. Okay, and you can also do a factory reset. And I think that's it. Yeah, in terms of settings, that's it. Yeah, nothing more. Okay, let's go back. Let's see how we do that. I don't know yet. Okay. Power? No. Power shuts down. I don't think that we have a back button. Okay, so let's start now with the oscilloscope. This is a very familiar screen. You have a lot of information on the screen. Let me just bring my pointer. So we have the trigger mode right now, the auto, the slope, rising slope or falling slope. This is the function generator output indicator, and obviously the battery indicator. You have in here the buffer arrow. to move right or left. Also the line, and obviously the amplitude, the 500 millivolts per division. In terms of amplitude, we are using ×1 probe mode, and also in terms of time division, we are using 500 microseconds. AC coupling, and right now it is running. Let's press run. Okay, stop. Nice. So now let's try the keys. We have the auto. Okay. It takes a bit to do the auto, but we don't have anything connected, so it might take longer. Let's change the mode. So this will change the trigger mode. Right now we are on single and normal, and back to auto. Okay. The up key should bring the, I don't know why it's not moving the line. Maybe we need to, okay. And for selection, we use this. Right now I have the arrow, the yellow arrow here, and now I should be able, I should be able to move the line on the screen. Okay, very nice. So if I move again the arrow to the amplitude, it will allow me to change the amplitude. Same for 1 time or 10 times. Same for time division and AC DC. And finally the trigger. Okay, pretty simple to use. Yeah. If you press on the top for a bit, it will allow you to set the 50% on the screen. And if you press for a long press the top one, it will give you the menu. So that might be the case with this. When we were here, just need to press, for a long press, it will give you the main menu. Okay, very nice. Only 2 more things to note. If you press modes for a bit, it will change the edge of the signal, rising edge or falling edge. Yeah. And if you press run, you can activate or remove the measures from the screen. Okay, that's it. Again, if you press for a while in the knob, it will take you to the main menu. Let's see the signal generator. Okay, in terms of signal generator, if you press run, I believe it will activate or deactivate. Right now it's not active. Let's see on the oscilloscope. Yeah, the signal now it's deactivated. Again, main menu, signal generator. So right now it's on. For what I can see, we have 99 kilohertz of frequency on sine wave. Okay, maximum. What kind of waves do we have? Let's first see how we can change these. Pressing on the knob will allow you to position, activate the digit, and I think you can position the digit and then use these keys to get the value that you want. Okay, going down, you can change the duty cycle of a sine wave. Okay, and the amplitude also. In terms of signals, you have the sine wave, square wave, sawtooth, half wave, full wave, step wave, reverse step wave, noise, index up, index decrease, direct current, multi-audio, sync, and Lorentz. So all summed, there are 14 signals available for you. Not bad for a device of this price, and again, very nice. So I will test this function generator a bit more ahead in the video. Right now, what I will do is connect this to my function generator so we can test the oscilloscope. I have my setup already in place. So on the left you have the oscilloscope, on the right you have my XDG 2100 function generator. It is outputting already a square wave with 1 kilohertz, and as you can see, I just compensated the probe and we have 90-degree angles on the square wave. Very nice. So since we are on the square wave, let's increase this up to 100 kilohertz. Okay, let's do it auto. Okay, 100 kilohertz already jiggle a bit. On square wave, I don't believe that this will be able to go all the way up to the 1 megahertz. So let's increase it manually, 100 kilohertz at a time. So 200 kilohertz, 300, 400, and 500. Let's do an auto at this moment. Okay, we have serious deformation already in the square wave, but since I'm outputting 1 volt VPP, right now it says 1.18 volts. That's a bit strange. It's over the output VPP, but anyway, that's what is being detected. Let's continue up to 1 megahertz. Okay, 600, 700, 800 kilohertz, 900. Well, in here is already failing a bit, the detection. So we are at 1 megahertz. Let's see what we have with this square wave. Yeah, there is something fishy in here. We have 1.2 VPP. I don't know. Okay. Anyway, this is a square wave. Let's change to a sine wave and go back to 100 kilohertz to see what we got. Let's do an auto. Okay, it takes a bit to do the auto, but seems okay. This seems more like it. We have 1 volt, 980 millivolts to 1 volt in VPP. It detects 100. It's jumping a bit. Yeah, it's jumping a bit. I don't know if this is, but it detects sometimes the 100. Let's increase it. 200, 300 kilohertz, 400, 500. I will do an auto at this point. Yeah. Okay, let me just adapt here. Okay. The sine wave is not bad at all, at half of the capacity in terms of analog bandwidth. It says 900 millivolts, so it's over 720-ish millivolts of the minus 3 dB. Let's continue. 600, 700, 800, 900, and 1 megahertz. Let's do an auto. Okay. I will try to see. Yeah, 500 nanoseconds is the maximum or minimum that we can have here. The signal itself, it's not bad. I believe that this will be very useful for hobbyists and even in some professional cases. But yeah, this VPP, I think that is something fishy here. But 1 megahertz, 1 volt VPP, seems nice. Let's take this to 2 megahertz to see what happens. Okay, it goes down to 820. The signal is totally rubbish. 3 megahertz, 4 megahertz, and 5 megahertz. He goes bananas. Never mind. But even on 4 megahertz, it reads a maximum of 1 megahertz. So let's do an auto. Yeah, the sine wave is good, but the frequency read it's 1 megahertz, and in theory you shouldn't have 950 millivolts VPP when you are reading a 4 megahertz on a 1 megahertz oscilloscope. So yeah, the sine wave, it's not bad at all, but something it's not right for me right now. But in terms of signal, it's pretty good. I am outputting 4 megahertz signal. If I go to 5 megahertz, I don't believe this will be of any use, but let's see. Do an auto. Well, he was able to draw the signal, but yeah, it changes the frequency. It was some weird value. Yeah, it kind of works with it, but well, I cannot complain because this is 1 megahertz oscilloscope, so in the maximum, and you should never go up to the 2/3 of the capacity of the oscilloscope while analyzing a signal. 1 megahertz, let me do an auto again, just to be sure. So yeah, 1 megahertz with a 1 volt VPP, it's exactly what the function generator is outputting. So I'm pretty happy with this. I cannot prove that something is hammered here, so I have to believe that this is right. Okay, let's now do the inverse. Put the function generator working and checking on my oscilloscope what are the results. So in terms of signal generator, I am already outputting a sine wave to my oscilloscope, my Rigel, as you can see in the screen. I was kind of surprised with this function generator. The maximum frequency, it's 10 kilohertz, so 10,000 hertz, but it will handle pretty well at the maximum, as you can see in the screen. Let me change for square wave at the maximum. It's pretty smooth. Yeah, the several. Let me just do it auto to see if we can fixate this. Yeah. So right now we are off wave, full wave. This is the step wave, reverse step wave, noise, index up, and index down, decreasing. This is the direct current, so this is a signal of 3.3 volts. Okay, but also we have the multi-audio, how is it? Multi-audio, how he calls it. Okay, and sync pulse and Lawrence, I believe. Yeah, let me just do an auto again. Yeah, and Lawrence. So as you can see here in the oscilloscope, all values are very stable, too stable for my understanding, but if we change the several waveforms that we have in here, now this one is oscillating a bit. That reproduces also in the values we have on the screen. But again, this is very good for such a small device. Okay, the results are pretty good. All the waveforms are very well drawn. The values registered, like the frequency. Let me just add, I think, okay, we have now VPP on the screen also. So we are outputting 3.3. and the average and the current is 3.4, is oscillating between 3.4 and 3.3. So also very good. Let's go again to the sine wave. Yeah, very stable, everything. Let me do an auto so we can have this. Yeah, full wave. Okay, so let's try to change the amplitudes. Okay, 2.3, 1.3. Okay, let's do auto again. Yeah, if you do an auto, it will fixate the signal very well. Pretty impressed. Pretty impressed. Yeah. Let's put this again. 3. So that's it in terms of the signal generator. I think that we can force this a little bit with this such a good signal. Let's see if I can take this like 20 megahertz, sorry, to 20 kappa. Let's see if I can take this to 20 kappa hertz. Okay, that's pushing a bit like the double. And yeah, it's outputting a signal of the double of the function generator. The square wave still looks good. Well, those need to do an auto. Let's leave it. And yeah, everything looks good at 20 kappa hertz. It's the double of what is announced in the function generator. We have it here, 20 kappa hertz at 3.3. Very nice. Let's see. I don't think I can take it much more up, but like 22. It's detecting 22 already. Yeah, it's the maximum. After that, it goes bananas. Yeah, 22. But even so, it's more than it is announced on the user manual. So one thing that we should now check is if we can use the function generator or the signal generator while we are using the oscilloscope. I already set up a 1 kilohertz sine wave. Let's go to the oscilloscope and do it auto. Okay, and here it is. Let's try again. Okay, and we have our sine wave. It detected 1 kilohertz frequency and a VPP of 3.6. Well, it should be 3.3, but okay, that's good enough. Yeah. Let's change this to a square wave. Okay, also good. Let me now try to increase, okay, to 10 megahertz, the maximum auto. Well, the frequency was already detected, also the VPP, and a perfect square wave at the maximum of the signal generator output. Well, at least with the user manual. So the answer is yes, it can work with the signal generator at the same time it works with the oscilloscope. One thing that didn't work, well, it worked, but it didn't show. If you use the charger right now, in the previous model, you will not have any information that the battery is charging. Right now, you have. So this is a pretty cool improvement. You can see it here. And I'm also answering another question, that is if you can use everything while it's charging. Yes, you can. I'm doing it. I have the function generator outputting a square wave, and I'm using the oscilloscope while charging, so it's okay. Well, right now I'm just going to do a small comparison between the two devices. One thing that you should immediately notice is that we don't have this menu. If you press, as I showed you, in the menu here for a while, it will show you this menu, okay? But if you press here for a while, what will happen is it will show the menu for calibration that I don't want. So we don't have neither the signal generator or the settings menu. And if you are using the oscilloscope, as you can see, we have much more information in terms of measurements. In here we have 8 measurements, and in here we have 12. Another thing that I think that you can understand, the graphics are much worse in this. Well, the screen should be the same in terms of hardware, or almost the same, but the graphics that are drawn in the screen are much worse. We can see all the pixels in these small badges, while in here everything is smooth. We don't have that kind of pixelized information. So also the grid and everything else seems much more worked in terms of development. In terms of functions, you don't have the battery indicator, neither obviously because it does not have the function generator indicator. This is basically the 150 with a better shell, a more modern shell that we can use. Okay, that's the main differences between both of these devices. Obviously, on top you have two connectors on this one. And yeah, that's it. Now is teardown time. Okay. This seems to have much more components than the previous model, but I will compare it before going to the microscope. Let me just take the rest of the case. Okay, just for fun and to show you the differences, this is the board from the DSO-152. As you can see, it's much simpler. And this one is the board for the DSO-153. Obviously, you have here function generator included, an additional DSO output, so you should have more components, but this is just for curiosity what you have in here. Okay, let me put this under the microscope and let's continue. Okay, so I have here under the microscope the board. Let's start from the top. We have here this little knob. It's also a switch, as you can see. It's a selection knob. Then on the right we have the output for the square wave for compensation of the probe, and more at the right side we have also one of these is the probe input and the other the signal generator output. Since this is in reverse, I don't know which is one, but I believe this is the signal generator output. Okay, so let's start with the ICs. I will leave this to the end because it's also, as usual, scratch. Not sure if this is the main processor or just the ADC, but it's scratch, so no big deal there. Okay, so to the right we have this on the subminiature relay. This appears a lot in these small devices, and also in the right side we have this Cosmo Y214S. This is a solid state relay with a MOSFET output, And let's go to the side. What else? So we have here the switch for reset. Okay. And somewhere here should be the light also for the charging. We have the USB port for charging. And this one is the TC4056A. So this one is a linear charger for lithium-ion batteries with constant current and constant voltage. I think that normally we used to see the TP4056A instead of this one, but this is the option on this device. We have here the power connector for the battery. And yeah, let me turn. We have in the middle this TC-HC4051D. This is an Xperia IC, but it's the old Philips one, the ones that used to be from Philips. So it's a 8-channel analog multiplexer, demultiplexer. Also on the left side, we have this GS8092. I believe that we have 2 or 3 in this. Let me check. I'm only seeing 2. Yeah, it is probably 2 only. We have one here and one here. And so this is a dual 350 megahertz CMOS rail-to-rail output op-amp. Okay, and also, well, we saw this already. It's a scratch IC. Okay, we are almost at the bottom, and okay, we have a lot of these LB33 with 3 units here. Okay, so this LB33, it's the MIC 5205. It's not more than a linear voltage regulator with a very low noise output. Okay, I think we are done in terms of ICs. Okay, that's it. Let me close this and continue. Let's wrap this up, and like I've been doing lately, I will start with the price. This mini oscilloscope is being sold on the official FNIRSI AliExpress store for 29 euros for the basic set or 32 euros if you include the probe. That is around $31 for the basic set or $34 for the set with the probe and the MCX adapter. Considering that if you buy just the adapter alone, you will pay 2 to 3 euros, 3 more euros for the adapter and the probe is a good deal, as it is also the oscilloscope. For 29 euros you get a reasonable enough oscilloscope for your DIY projects and even small fixes. I like everything about this oscilloscope. The case, the UI, how easy it is to operate it using the knob and the buttons. And in the addition, the function generator, that works pretty well. I love this function generator. FNIRSI is doing a good job improving these low-budget devices, upgrading its features and specifications. There is a lot of engineers that will consider this a toy oscilloscope, and I understand what they mean. But this device is capable to help you a lot in not so demanding tasks where you just need to analyze a signal, and the upgrade to 1 MHz, it will increase the number of situations where you can use this oscilloscope. For learning, students and hobbyists should be more than enough. One final note was the interface graphics quality. They were hugely improved and is now much better experience for working with it. Even with that suspicious VPP value in the bandwidth analysis, that until proven otherwise I should believe, the overall experience was pretty good and I liked a lot what FNIRSI did with this device. If you have the same opinion and you are considering to buy one, let me suggest the usage of the affiliate access links on the screen or in the video description. If you are interested in becoming a channel sponsor while making your purchases on AliExpress or Amazon,
and without paying a cent more for your purchases. All the help is really appreciated and all the value is reinvested on the channel equipment for better reviews. And if this video was useful to you, please help me spread the word and slap that like button. And allow me also to suggest that you subscribe if you haven't done before, so you can be notified whenever I review a new product in the market, like this new DSO-153. That's it for today. Thank you for your company and for watching this video, and I hope to see you on my next one.